In the Analyze module, we have a matrix viewer that gives you quick insight into the entire FRF matrix. Up here, you see which FRF dataset is being displayed. By default, the matrix shows data from the measured FRFs. Within the matrix, there's one column for each impact and one row for each response channel. So each box represents an individual FRF. The settings down here control what exactly is reviewed in the boxes. So in this case, we're looking at the average coherence from 0 to 6400 Hz, but we can change these settings to review different quantities and ranges. Within the matrix, higher values are shown with darker colors and lower values are shown with lighter colors. We can zoom in by clicking and dragging on the axis, and reset the scale by double-clicking. If we hover over the boxes, we see the name of the response and excitation for that specific FRF, along with the value of its mean coherence, as that's what we're currently reviewing. When we click on the box, that FRF is shown in the graphs card, and additional information for that specific FRF is shown in the validate card. Clicking on FL, the frequency lock button, will ensure that the x-axis of the graphs will match the frequency range set in the matrix viewer. We can zoom in on sections of the matrix viewer by clicking and dragging to create a box, or using the scroll of the mouse. Double-clicking always resets the view to the full matrix. We can also zoom in and out of the matrix using the arrows on the axes, as with regular plots in Dirac. In the Validate card, the individual measurements for the selected FRF are displayed. And just like in the Measure module, we can star, delete, or toggle them on and off. We can also review the overall response and force consistencies in the Validate card. The box we've clicked on contains an FRF with responses tied to VP1, so VP1 is listed here, but we can also review consistency for the other VPs here. Since several channels are used together to calculate virtual points, the overall response consistencies for all channels tied to VP1 are listed here. These consistencies are the average across the chosen bandwidth. Using the spacebar, we can see how removing individual channels from the VP calculation will affect the consistency of the remaining channels. The force consistency is used the same way. For any data measured in Dirac, the matrices for coherence and magnitude will be fully populated. But let's check out the response consistency. As you see, in this mode, the bottom 3 rows are gray. This is because we can only calculate response consistency for channels that are tied to a virtual point, so not for our validation sensor. Now the graphs in the middle also have a new pink line. This pink line is the result of transforming the response of the FRF to the virtual point and then transforming it back to the original sensor. The lower graph shows the consistency between the pink and blue FRFs. If we average this consistency function over the defined bandwidth, we get the numbers in the boxes. Then combining the response consistency of this FRF with others in this row, using some of Martin's fancy equations, we get the overall consistency bars in the Validate card. The force consistency mode pretty much works the same as response consistency mode, but operates on forces instead of responses. If we go to reciprocity mode, the whole matrix is gray. This is because we don't have inputs and outputs at the exact same locations in the measured FRF matrix. To review reciprocity, we have to look at the VP FRFs by clicking here. In this mode, with co-located inputs and outputs, we can assess reciprocity. Now clicking within the matrix shows us the VP FRFs in the graphs card. The selected FRF is shown in blue and the reciprocal FRF is shown in orange. The similarity of these two reciprocal FRFs is shown in the bottom graph. Aside from the measured FRF and the VP FRF, we can also review data with other preset channels, or create our own custom matrix. combining any selection of measured and virtual point channels and reference channels. In the 3D viewer on the right, when we animate the operational deflection shapes, we only animate the channels that are included in the selected FRF matrix. Here you see we're animating the virtual points on both sides of the structure, and also the sensors on one side. These are the channels that we selected in the matrix. This was just a short overview of how to use the matrix viewer. There's a lot you can do with it, and hopefully now you feel ready to get started.